Hello, welcome back. I hope you guys are learning a lot of acid and bases. I know this might be boring. You're just doing work continually, watching a video, doing work. But the whole concept of this, the whole idea of this is that as you work through this, if you have any questions, please don't hesitate to ask, so that I do have time to work with you one-on-one as you need help. Okay, don't feel embarrassed if you don't understand something, ladies and gentlemen. I'm here to help you, so if you don't understand something, it's not your fault. Unless you're not really trying, then that's on you. But if you're trying, I'm more than willing to show you and walk you through this if you don't understand it. Okay, but you please put out the right amount of effort so that you can learn all these materials that we need as we finish the end of the year. Make sure that you don't give up. Okay, no matter what point in time is, we are still in school. You're here to learn. I am here to teach, and so this is not a way for me to get away from teaching, or so I can sit back and relax. But it allows me to help the people who do need help, because this is a new concept and it could be challenging for some of us. So please don't feel scared of asking questions. Okay. All right, so one of the last things that we are covering in, not the last thing, but one of the last things we're covering in acid base is pH. Okay, this pH worksheet there, it's all jumbled up here. I'm sorry for that. The editing isn't quite perfect. But pH, remember, pH is the power of hydrogen ions. So basically a measure of how much hydrogen ions are in the solution. So a few things you will see. You'll see things in brackets, and from the last video, things in bracket mean is this concentration, how many, the capital M, how many molar, and it's molarity. Okay, so capital M, and you see interchangeable with that is a hydronium ion, very similar in terms of what it is. It's essentially the same thing. Okay, then on the other hand, bases will have OH concentration. And if we remember from the last video, the H and the OH concentration always multiplies together to get 1 times 10 to the negative 14. Okay, that is the magical number there. So remember that. And if you don't, this is usually provided. This is going to be provided for you. All this information here on top that you see will be provided to you for tests, quizzes, and things like that. But it might not show the H3O. Just know that H3O and H plus are interchangeable. They're essentially the same thing, because they're in water and they will form those ions. Okay, and it's fairly, you have to understand how to do these. Once you do that, it's fairly easy. It's all calculator work, really. I don't know how to do logs without a calculator, so you have to have a calculator with the log function. On the yellow calculator, it is this button here. It's right at the 10 to the x right there, and you have to use the control. Since it's in yellow, you have to put control, log, and then, holy smokes, what is this? Hold up. Calculate, okay. Second, log, oops, what is this? Control, log. This is base 10. You have to do all that? That's crazy. So it's log base 10, it's standard, log base 10. So that's too fancy. We'll see if we get the same answer in a little bit. Okay, so pH is negative log of H plus. pOH is negative log of OH minus. Okay, and the pH plus pOH always equal to 14. If you remember that much, this should be fairly easy. Even though you don't have to remember it, but if you remember it, it helps you so much. It makes doing this so much easier, and so you should be all right. Here, determine the pH of a solution with that much H. So H, it gives you H plus, then you can find the pH. pH is equal to negative log of the H plus, which is 0.5 molar. Okay? And the rest of it is really calculator work. So, I forgot to put negative. So, let's go back. Negative, log, control, log there. Base 10, this is too much work. 0.5. We get 0.3. Let's see if the blue calculator will give us the same answer. Negative log 0.5. 0.301. 0.301. Oh, good. It does give us the same answer. So the pH of this is 0.301. That's the pH. Okay? So that's really what the pH is. This is so low. This is probably not a real thing as far as half a molar. The pH is so low. This is 1, so it is very, very dangerous. Very, very strong acid there. 1 is already strong. 2 is strong. So it's a very, very strong acid. Okay, number 2 here. Determine the pH if the pOH is that. This one you have to get pH plus pOH is equal to 14. Sorry. pH plus pOH is equal to 14. So you can figure out what the pH is from this. You can do that. Okay. Number 3, determine the pH of a solution with that OH. With that, you can find the pOH. pOH is negative log of the OH concentration, which is that. Negative log of 1.5 times 10 to the negative 5. Okay. I like to use the green calculator. I think it's just better. Negative log. The log is right there, right above the second button. 1.5 times 10 raised to the negative 5. And the pOH is 4.8. Remember, this is the pOH, okay? Because we used the concentration of OH. So what's the pH? So basically pH is equal to what? pOH plus pH gives you 14. So pH is basically 14 minus 4.8, which is 9.2. So this is the pH. Okay? They need to add up to 14. pH and pOH. Add up to 14. Okay? Pretty easy. Sounds good. And the next one here, determine the H plus concentration with the pH. So if they give you the pH already, then to find the concentration to go back, here's the formula up here. The concentration, to get concentrations there, H plus is 10 raised to negative pH. OH minus is 10 raised to the negative pOH. Okay, so H plus equals 10 raised to the negative pH. And so we have that. So 10 raised to the negative 2.81. Just type that in your calculator. Here you go. 10 raised to negative 2.81. Hit enter. There you have it. 1.0.00155. I'm gonna round that to 5. Go. 0.001548. So when you see this, please write this in scientific notation, because most of concentration are scientific notation. We move the decimal places 3 to the right, so it's 1.55. Get one number in front of the decimal. Get one number in front of the decimal. And since we move the decimal place 1, 2, 3, it's times 10 to the negative 3 molar. So this is the H concentration. Okay? H plus. And that answers the question. Alright. And number 5 is very similar to what you did last time with dissociation. Because you use the equation H plus times OH minus gives you 1 times 10 to the negative 14. Voila. How cool is that? Okay. So what you need to do is you need to practice on number 6 through 10. And please don't hesitate to ask questions when you don't understand any of this. Okay. I'm ready to help you. So make sure you learn this today. After you learn this, go back on your standards, on your rubric. Remember the rubric when we circle all the ones? We started with where everybody's on level 1. And so now you have learned how to calculate pH from concentration of hydrogen and hydroxide ions. Okay, so you've done that. You've learned how to calculate pH from concentration of hydrogen and OH ions. In fact, you've learned a lot more than that. So keep this in mind, ladies and gentlemen. Do your best. And goodbye.